here's how to do box plots in math. So first things first, whenever you get a list of data, you want to take that data and put it in order from least to greatest. So in this case, what I like to do is I like to underline as I go. So I see the smallest value is 2. The next smallest value looks to me to be 5. And there's 2 values that are 5. So I'm going to do those 2 5s. And make sure you don't lose any data. So even though you have 5 repeating twice, you still have to include it twice in your list. So 2, 5, 5. I see then 6. So then there's a 6. I see no other 6s. I see a 7. Ooh, 7. And I see an 8 and another 8. So that's 2 8s. And I see a 9 and a 9. And then there's a 10. So I got 9, 9, and 10. And I can underline all of them. I like to underline it better than I like to cross it off. I know some students like to cross things off. One moment. All right, so I like to underline it, like I was saying, more than I like to cross it off because I think that keeps the data a little easier to see. All right, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pieces of data. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pieces of data. So we didn't lose anything. That's exactly what we want. Once you have it in order from least to greatest, you're going to ask yourself, what is the median? What is the middle value? Because this is an even list, there's 10 items, there's no true middle. So 1, 2, 3, 4, 5. That means that basically these two are going to be in the middle, right? 7 and 8. So the true middle is going to be halfway between 7 and 8, or the true median. So what's 7 plus 8 divided by 2? 7.5. So I just do a little arrow here and I do 7.5. And that's telling you what your median is. Your median is 7.5. Because there's no median on the list itself, we're going to separate this into an upper section and a lower section simply by including the value that we averaged that's on the low side with the low side, and the value that we averaged the high side on the high side. So those basically those rectangles represent our upper and lower data. So I'm going to label them with a little upper and a little lower. So this is the upper section of our data, the upper half of our data, and this is the lower section of our data. Okay. Once you have your upper and lower section, you can look for your quartiles. Your quartiles are the medians of the upper and lower section. So in this case, with this upper section, you have a true median of 9. So that is what we call the upper quartile. So I'm going to put UQ underneath it. Okay, in the lower section, you have a true median of 5. That is what we call the lower quartile, or LQ. The extremes are the highest and lowest values. The highest value is, of course, 10, which is going to be our upper extreme. And our lowest value is 2. That's going to be our lower extreme. You can use a maximum as the word for upper extreme, and you can use minimum for the word for lower extreme. It's the same thing. Once you guys have all 5 points of data for the box plot, you just need to make a number line to put your data on a box plot. So in this case, I've got a blank number line. I need to go from 2 to 10, and I can count by a consistent interval. So I'm just going to literally just go 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm going to count by ones. Once I have that set up, I'm going to put in all of my dots for my box plot. I'm just going to use this line right here. It's a nice, easy place to put it. So 7.5, it's right here, halfway between 7 and 8. Then you've got your lower quartile at 5, your upper quartile at 9, your upper extreme at 10, and your lower extreme at 2. Then you're going to make your box, which is always going to be from quartile to quartile. So this is going to be from 5 all the way to 9. And you're going to draw a line down where your median is. Okay? And then you're going to extend to the whiskers. So let's do that with a little line segment here. Just like that. And just like that from quartile to extremes. Remember, the wider your box is, the more spread out your center 50% of your data is. The wider, the longer the whiskers, the more likely you have an outlier. So in this case, it's much more likely that we have a low outlier than a high outlier, and that makes sense. The 10 is close to the 9, they're not really far apart, but the 2 is pretty far away from the 5. So our outlier would be 2, right, in this case. Once you have done all of that, you're going to go down and try to figure out the other values you need, the mean, median, mode, and range. Now we already have the median, which is what, 7.5. So on this little answer document here, we can put 7.5. In terms of the mode, that's the one that happens most often. Now there's several modes here. You've got 2 5s, you've got 2 8s, and you've got 2 9s. So that's a tie for the mode. The most frequent is actually 5, 8, and 9. So you're literally going to write 5, 8, and 9. All three are the modes. Okay? The range is the change from the highest to lowest, or from the lower extreme to the upper extreme. That's from 2 to 10. What's 10 minus 2? 8. So your range is going to be 8. Now remember, there's also the IQR, or interquartile range. That would be the range from quartile to quartile, which in this case would be 9 minus 5, or 4. But it doesn't ask us for that, so we don't need to worry about it too much. But if someone did ask you, that's what you'd do. Then the harder ones are the mean and the mad. Now in order to do the mad, you have to calculate the mean. So to calculate the mean, you're just going to take all these values, add them up, and then divide by the number of values. So you're going to do 2 plus 5 plus 5 plus 6 plus 7 plus 8 plus 8 plus 9 plus 9 plus 10. And then you're going to divide that by 10, because there are 10 values. So you're going to divide all that by 10, and that's going to be how you're going to calculate your mean. All right? So in this case, our total on top is going to be 69, and we're going to divide that by 10, so our mean is going to be 6.9. So our mean is 6.9. Let's go down and put that in our list. Now, to find the mean average deviation, or sometimes called the mean absolute deviation, or MAD, what you're going to have to do is you're going to figure out how far is, on average, is each of these data points away from the mean. So basically what you're going to do is pretty simple. You're going to take each data point, you're going to subtract it from the mean, and then you're going to take the absolute value of that. Those are called your absolute deviations. You're going to add all of those together, and then you're going to divide by the number of deviations. So ultimately what this looks like is the absolute value of 2 minus 6.9, and then the absolute value of 5 minus 6.9. Now because there's two of those, I'm going to multiply that by 2, because I could write it twice, or I could just make it a little more convenient for myself by doubling the results. For the next one, it's going to be the absolute value of 6 minus 6.9. And then you're going to do the absolute value of 7 minus 6.9. And then you're going to have the absolute value of 8 minus 6.9. Once again, that's happening not once, but twice. So I'm going to put 2 there. Then you have the absolute value of 9 minus 6.9. And that's not happening once, but twice. I'm going to put a little 2 there. And then you got 10 minus 6.9 as the absolute value. And all you're going to do is do those subtractions, and then multiply, if you need to multiply, by the frequency that they occurred. And then you're going to add all that together to get your total absolute deviations. Okay, I'm not going to bore you guys with that. I'm going to pause it and do that, and then I'll show you the answers. So as you guys can see, now we've got all these absolute deviations. The trick here is, like I said, 5 take away 6.9 is going to be 1.9 negative. Absolute value of that is positive 1.9. And then you're going to double it because it happened twice. Hence, the total absolute deviation there was 3.8. Once you get all of these values, you're going to add them together. So I'll do that now off camera. So after a brief moment with the calculator, the total absolute deviations would be 19.2. And all I did is add all these pink values together, right? So the total absolute deviations is 19.2. Then you just got to take that and divide it by the number of deviations, which happens to be 10, right? Because there's 10 points of data. And so then you're going to get your MAD, which is 19.2 divided by 10, which is 1.92. So you're going to get 1.92 as your MAD. And that tells us that, on average, each of these values was 1.92 away from the mean of 6.9. Okay? So it's a measure of the spread of the data. And that's how you do it. Now let's jump in and try the second data set. So for the second data set, the process is basically the same, except this time you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 pieces of data. So now you have an odd numbered list. So the first step is the same as before. You're going to just put this in order from least to greatest carefully. So the smallest value that we have is 9. The next smallest value that we have is 11. The next smallest value that we have is 13. The next smallest value that we have is 15. It happens not once, but twice. Oh, 3 times actually. So we got 15, 15, and 15. And then the next value is 17. Then you've got 18, it happens twice. So 18 and 18. And then it looks like you have 19, it happens once. And finally you have 20. So there we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 pieces of data. We didn't miss anything. Now we're going to ask ourselves, is there a true middle? And because there is 11, which is an odd numbered list, there is a true middle. So there is a true middle. Let's find out what that is. If it's 11, it's going to be 5 on either side. So 1, 2, 3, 4, 5. So our true middle is this value right here, which is your median, which is going to be 15. Okay, scroll up so it's a little easier for the computer to recognize what I'm doing. So there you go, 15. Okay, that splits the data into a low and high side. So remember the difference is when you have an even list, like this one up here, you had an average to get to that middle, okay? So that the one that you average on the high side stays with the upper side. The one you average on the low side stays with the lower side. But when you have an odd list, because there's a true median on the list itself, when you split the data, that median is not part of the upper or lower. It's directly in the middle. So you've got the upper side on the right of it, and you got the lower side on the left of it. That's the difference between an odd list and an even list for a box plot. So taking a look at what we have here, hopefully we're all on the same page. You've got the upper section here, right? The upper half of the data. You've got the lower section here, the lower half of the data. The median of the upper half is going to be your upper quartile. In this case, you got 1, 2, 3, 4, 5. So there is a true median, 18. That is what we call the UQ or upper quartile. The highest value is the upper extreme. So we can call that UE or upper extreme or maximum. The lower quartile is the median of the lower part of the data, which is in this case 13. There's a true lower quartile there. And then, of course, they have the 9 as the lowest value. We call that the lower extreme or minimum. Right? These are the 5 points of data you need to make a box plot. Now we need, in this case, our values to go from 9 to 20. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. If we just counted by ones, it wouldn't work if we started at 0. But if we're going to start at 9, it will work just fine. So let's just start at 9. Okay, so we're going to start at 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. Okay, so we label a number line. Next, we're just going to take these values and put them on the number line. So your lower extreme is 9. Your lower quartile is 13. Your median is 15. Your upper quartile is 18. And your upper extreme is 20. And we're going to now do our box plot here. So you're going to do quartile to quartile to make your box. And then a line segment down the middle of the median to show whether we're skewing low or high. And then you do a line segment connecting from the upper quartile to the upper extreme, and from the lower quartile to the lower extreme. And that is how you create your box plot. Okay? So that's the first part we finished there. That already includes some answers to our questions down at the bottom, so let's fill in what we can fill in. We can see that the median we already had was, I believe, 15. So you guys can put that in, right? That's fine. The mean we haven't done yet. The mode is the one that repeats the most. So you've got 3 15s, and that's the only one that has 3 of them. So that's the mode. There's no tie for mode in this one. The mode is 15 as well. The range is the change from the highest to the lowest value. So in this case, from 9 to 20. What's 20 take away 9? 11. So your range is going to be 11. If someone asked you for the interquartile range, that's just the range from lower quartile to upper quartile. So in this case, the interquartile range would be 18 minus 13, which is 5. No one asked you for that, but if they did, that's what you put. Okay? And then we got to figure out the mean. Now the mean requires some work. So once again, I'm going to probably let the calculator do some of this. So let's write out what happens though. To find the mean, what you're going to do is you're going to add up all the values. So 9 plus 11 plus 13 plus 15 plus 15 plus 15 plus 17 plus 18 plus 18 plus 19 plus 20, which would be 11 things, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then you're going to divide by the number of items, which in this case is 11. So you divide by 11. And just to not bore you guys, I'm going to pause it, do it on a calculator, and give you the totals over here. So as I said, you get now a total of 170, and divide it by 11. So on a calculator, let's just do that real quick. 170 divided by 11. And you're going to get 15.45 repeating. 15.45 repeating. So 45, 45, 45, 45, forever and ever and ever. Now, in order to make our lives simple, I'm going to calculate the MAD using a nearest whole value. So if I wanted to use the nearest whole value, what's the closest whole value to 15.45 repeating? It would be about 15. So I can use that to calculate. If I want to be a little more precise, I could use 15.5. All right, let's be a little more precise. Let's use 15.5. So we'll use 15.5 as for the purposes of calculating our MAD. I think to the nearest tenth is accurate enough. So our mean is going to be 15.45 repeating. That's an exact answer. But when we do our mean average deviation, we're going to use 15.5 as our mean, just to make it a little easier, because we can't really easily work with this repeating decimal. So once again, the way that works is taking a look at all of our values here on our list. You're asking yourself basically, on average, how far is each of these data points from the mean? And the way that we're going to figure that out is we're going to literally keep track of these deviations and find the absolute deviation, because we don't care about whether it goes up or down. We just want to know how far. Distance is always positive. So what I'm going to write here is pretty simple. I'm going to write for the MAD, you're going to do absolute value of 9 minus 15.5. And then absolute value of 11 minus 15.5. And then absolute value of 13 minus 15.5. Then absolute value of 15 minus 15.5. But that doesn't happen once, that happens how many times? It happens 1, 2, 3 times. So I'm going to multiply that result by 3. Then you've got the absolute value of 17 minus 15.5. Then you've got the absolute value of 18 minus 15.5. But that doesn't happen just once either. The 18 happens twice. So you're going to do that result times 2 to get the total deviations for that. And then you've got 19 minus 15.5. And you want to take the absolute value of that. And then you've got 20 minus the 15.5. And you want to take the absolute value of that. Okay? So we can do all this on a calculator in terms of the differences, and we can come back and see what that looks like in a moment. So that's what I'm going to do, so that you don't get bored with me typing things into a calculator. So as you guys can see, after I get the absolute deviations, I can now add all these absolute deviations together to get the total absolute deviations. So let's do that. So the total absolute deviations is going to be 6.5 plus 4.5 plus 2.5, and so on and so forth. I'll do that and I'll get back to you in a moment. All right, so our total absolute deviations is 29.5. And remember, for like this one here, I did 15 minus 15.5, which is basically negative 0.5. The absolute value of negative 0.5 is 0.5, and then times by 3, you get the 1.5, right? Because it happened 3 times. But anyways, so once you add up all those values, you're going to get 29.5. And then to find out the MAD, you're going to take these total absolute deviations from the mean, and you're going to divide by the number of deviations, which happens to be 11, because there's 11 pieces of data, and that will be your MAD. So our MAD in our case is 29.5 divided by 11, which is 2.6818181818. So that would be let me write that a little nicer. 2.6818181818. So like that. And that, I think, matches that, 681818. I think you could probably actually do 81. Let's just do 81. So you can do 2.681 and put the bar over the 81, because that's going to still be 181818 forever and ever. All right, so there's our answer. Now you can approximate that if you wanted to the nearest tenth at approximately 2.7. So when we go to our MAD, Move my little face away. You see our mean absolute deviation, our mean average deviation is going to be 2.7 approximately. So 2.681, which is approximately 2.7. What does that mean? It means that on average, each of these pieces of data is about 2.7 away from the average, right? That's the measure of spread, right? How far each of those pieces of data is from the median, okay? And that's how you do all that math.